I'm the professor of Faculty of Science at Technology University, and I'm now the president of the Japanese Society for Artificial Intelligence, so-called JSAI. And my specialty is multi-agent, small intelligence, computational science. I edited some biography here. And nowadays, one of my recent work includes developing interactive AI to utilize generative AI to innovation. For like this cartoon was created by the creators using or developing. Okay, my Satoshi the current work, recent work, I include the developing interactive AI and to utilize the generative AI for innovation. Okay, and this cartoon is created by creators using or develop AI. Yeah. So let's start my talk. Okay. I'm sorry. I can. Oh, so yeah. Okay. Yeah. So at first, I would like to look back the history of AI. Of course, yeah. I will also know, and I will think about what we have learned from the history. So of course, during first AI boom, various methods like such algorithms were proposed, but unfortunately, computer performance at that time was relatively low. So this method couldn't be used for practical use. So first AI boom entered in the winter season. Okay. And from the first AI boom, what we have learned is first, the latest idea and method are not always immediately put into practice. That is, infrastructure for practical application must be in place, of course. And in the second AI boom, of course, everyone knows that the AI boom was boosted by knowledge processing such expert system. But unfortunately, computers at that time couldn't handle our common sense. And from the second AI boom, we have learned that the amount of our knowledge, like common sense or touch knowledge, is enormous. We have learned, okay? But that computers that time couldn't handle processing this big knowledge, big information. Yeah. Then, of course, and also second AI boom, of course, entered in the winter season. And current, we are in the third AI boom, of course, due to the commercialization of deep learning, and especially the birth of generative AI has further boosted this current third AI boom. Okay. And at this point, I have one question: how the first and the second AI boom really failed? My opinion is that I don't think so. But the first and second boom, I finished the success, I want to say. That is the meaning of third current AI boom is the first AI boom was complete successful, I think, because by infrastructure in place to, for example, deep learning in practical. And as for second AI boom, of course, I think of that is complete successfully, thanks to the successful development of GPT-4 level LLMs. That is GPT-4 level LLM has enabled AI to deal with the knowledge of common sense, which has been barrier for AI so far, I think, yeah. And of course, currently the generative AI era and the number of generative AI are appearing every day, yeah, of course, every day. So. And at this point, how will AI develop in the future? Okay, of course, this is in my topic in this presentation, yeah. And in other words, right? Yeah. What will the next wave after the current third AI boom? I think about this in presentation. Okay, and please this picture. Okay. And I would like to think about the 70 years history of AI from the first to the current third AI boom can be described as the era of tool-based AI, I think. Okay, and this picture shows a cooperative robot packing lunch box alongside a person. This, and however, it cannot flexibly change its behavior to adapt to person movement. Yeah, adaptively, it can't. So it only performs predetermined actions. Okay. So, yeah. So of course, this cooperative robot are also advanced tool type AI, of course, I think. But and they are basically system one type AI that react conditionally to input. Yeah. On the other hand, my idea, next era is the autonomous AI era, okay? And please see this picture. This picture. So Japanese person easily gets to this robot. This is very automobile companies very forces autonomous AI. This person, this left side person, yeah? This person slip. And at the same time, the robot put out his hand just in time to prevent the person from falling, okay? For him, of course, this person put out his hand, expecting that the robot will understand this situation proactively, maybe he think. This is a good situation with a symbiotic relationship. To make this, to be possible, in order to be able to understand the situation and act proactively, robots need a high degree of autonomy. Everyone easy to guess. And at this point, I will introduce a typical Japanese term, omotenashi. Do you ever know? Omotenashi is used very, I know some maybe everyone know worldwide, but omotenashi was a term used as a concept of Summer Olympic in Tokyo in 2023. So, okay. And omotenashi in English, hospitality or welcome or entertain, maybe, I think. And for my definition, omotenashi is to interact autonomously and adaptively with best possible interaction through understanding the other situation proactively and real-timely is my definition of omotenashi. So please see this illustration. And for one person, you seem thirsty, so have some tea. And this man said, oh, I wanted to have something to drink. Or another situation, this old man says that you wanted to go to the station this way. So this guy said, I was looking for the station. Thank you very much. This is a typical example of omotenashi interaction. And only the autonomous AI can perform omotenashi, I think, okay? And for the next generation AI, to enter our society, next AI, to enter our society and live in harmony with people, it will be necessary to be able to form a human-like relationship between people and AI, I think. And on this case, it is necessary for AI to be able to offer omotenashi, okay? And to make omotenashi require not only generality, but also a high degree of autonomy, I think. And this shows in Japanese problem, 2040 problem, the problem, still a problem in the nature, future, near future of Japanese aging problem, very sad problem. And this shows a situation of agriculture, okay? Of course, in this agriculture situation, farmer become older and less likely to hard work. In this case, one solver is to make a farm is a robotizing farm like automobile factory by introducing industrial robots like this. But I think in this world, humanity will be destroyed, I think. And I don't think that is a good situation. But of course, I think that human-centric society must be maintained to make this robot coming into human society. And what usually say that when in Rome, do as a Roman do. It's a very important term, I think. And to make this, a robot must behave autonomously by thinking about the farmer in mind, of course. Ooh. I'm sorry. Oh, I'm sorry. Oh, sorry. Yeah. And I'm a director, president of the Japan Society of Artificial Intelligence, I said before. And these are the heading of the article in Code Ethics in JSAI, divided by 2017, okay? And please, very easy to understand. And for 1 to 8, do you think about? Because 1 to 8 is very similar to other guidelines. But please see number 9. Number 9 is the avoidance of ethics guideline by AI. This is a very unique for the JSAI community. That is, this article says AI, we are going to develop itself, will have to comply with these guideline. And AI that comply in this article 1 to 8 means that this AI assumed to be autonomous AI. The very, so for Japanese people, they're very familiar to the autonomous AI. That is yes. In Japan, caution or threat against autonomous AI is not so high. because evidenced by the fact that the autonomous AI, along with appeared as a character in manga or anime or something like that, is a Japanese culture. It's very similar to think about the familiar feeling of the autonomous AI is a Japanese society. Maybe same as the Chinese. Okay. But on the other hand, this diagram, everyone knows that for categories of AI hazard in AU AI Regulation Act, and everyone knows that generative AI is included in high-risk AI system. And sadly, unfortunately, this one, autonomous AI may be assumed to be classified as the highest risk AI because autonomous AI will interact actively with human and be strongly involved in human thinking, of course. But remember that 2023 and the G7 summit at Hiroshima. And in this G7 summit, Japanese government announced that Japan's basic stance is to promote AI research and development. And of course, I welcome to this side. And of course, I would like to develop a Japanese-style AI with a high degree of autonomy and generality that can perform omotenashi, I think. And of course, but to think about the autonomous AI, but the autonomous AI is not so quite different from the true type AI. Rather than, I think the ability of autonomous AI basically same as true type AI. That is this line, AI at run human data cannot essentially suppress human, I think. That is in this human, of course it includes a genius that the average person doesn't understand level, of course included, okay? And this AI cannot invent things that human cannot understand, I think. That's the current true type AI, not beyond human, I think. So that, for example, even if AI understands the vast number of papers and generate generate a new hypothesis, even if those hypotheses are Nobel Prize worthy discoveries, even though this discovery will never leave the range of human compensation, I think. So, if so, will AI emerge which has the intelligence that human can understand? Here, usually we call the artificial super intelligence, ASI. Okay? If it emerge, it will be ASI. And if ASI emerge, and it will be the coming of the singularity, of course. But why I use the term emerge? So I use the create or innovate. I use the emerge. That is because ASI not something that human create. Okay, is my thinking. That is and of course I think that there is a possibility that ASI may emerge. And sorry. The clue of emergence is ASI scaling is my main topic of this presentation. So anyone know, at least see this picture of once. So this picture is a famous picture explaining scaling law in LLMs. Okay. So the success of ChatGPT development means that the scaling of data volume and the scaling of computing resources has dramatically improved AI performance. Very important phenomenon, I think. Okay. And to begin with, large quality change emerged by scaling, of course. For example, life has a high intelligence by human by emerges through scaling. Okay, of course a high level emerge from low level, or even nature is also composed by diverse scales. And the quality change through scaling is essential of the world, of course. And this is a very simple example. The example of shortest line emerges as a number of ants scales. And individual ant simply act freely, following the simple rule of interactive coordination by pheromones. Even though when a large number of ants act in the swarm, they generate the shortest pathway between food and nest. Okay? The important point is that even each individual ant don't understand that they are generating a shortest path. Okay, so each ant is using their rule itself, but they don't know that we are forming a shortest path. It's a very important point. That is the lower layers and the upper layers from which lower layers emerge have basically different dynamics. For example, this is each neuron and the collective intelligence emerging from brain. So of course, our brain emerges a high thinking ability, but each neuron cannot recognize what is emerging as a brain. To think so, I can see, I propose this figure. So ASI may emerge if autonomous AI is scaled, is my idea. But example, in this case, important point is that dynamic of individual autonomous AI and ASI are different. Is important. Same as the underlined. And intelligence, maybe intelligence of ASI cannot be understood by humans. And I imagine that for people, for us, impact of ASI will be the same level as a natural phenomena or natural disaster, something like that, I think. And however, intervention and ASI may be possible. That is, if the dynamics of lower layers change, dynamics of the emerged upper layer also change. That is, for example, this antline example, I explained using antline. So antline has a very high redundancy. Antline is an emergent phenomenon. And therefore, intervening into emergent antline itself is very difficult. But intervening into behavioral rule in each edge itself change what is emerged. Yeah. Okay. And of course, intervening into behavioral rule of each ant itself change what emerging. Is one clue of the control of intervening ASI. So now this sorry. Oh, yeah. So, however, so modifying the behavior rule of each autonomous agent, autonomous AI, may change the behavior of emergent ASI like this. So, but to begin, or it may be emerged because it requires so huge number of AI coordination or many resources. So something saturation maybe happen beforehand. Yeah. And also, even current AI possesses a threat to human survival, such as the generation of debugging fake or the AFR something like that. But I strongly discuss about the ASI in this presentation. Yeah. This is a conclusion remark. Human desire never stop. People seek. Technology evolves. And to next era is I think that true AI to also AI. For example, true type AI to symbiotic relationship between human and AI. And the omotenashi is an important keyword for autonomous AI, I think. And the data learning type AI is within human understanding, I think, basically. And the scaling autonomous AI could lead to the emergence of ASI. And the intelligence of ASI no longer within human compensation, maybe. But the emergence can be controlled by controlling coordination behavior each autonomous AI. So thank you very much.
Thank you very much, Kurihara Sensei. We have 9 minutes for questions and those all.
Could you please go to page 4?
Page 4. Yeah.
All right, that has to do with your evaluation of the AI history. And you said that the deep learning, practical, and the second AI boom was completed successfully thanks to the successful development of the GPT-4 level LLMs.
Yeah.
Now, I just let you know that I claimed or alleged that deep learning and ChatGPT suffer from 2 types of misconduct. One is cheating in the absence of a test. So all the things you're talking about, you say successfully, they are without the test. The second is the hiding bad-looking data because the less successful network that was trained was hidden, and what they reported is like the luckiest lottery ticket. And the lottery ticket did not have intelligence, but just lucky. And the successful lottery ticket for the next lottery round will be not successful. So if you look at that angle, then how do you evaluate the history of the first boom and a second boom. Thank you.
Thank you very much. Of course, you are thinking. Of course, I agree with you. But why I think the successful means, of course, for example, first and second AI is such a big wall is how to use common sense. I pick up this phenomena only, and in this case, GPT-4 level LLMs, I think something possible to use something common sense or touch knowledge. Therefore, I think something to second AI boom. Maybe my point of view is I can possibly to think about the success in the third AI boom, because current era, of course, many problems. Of course, I think so. So therefore, current, of course, but of course, in current AI, almost problem not so solved, of course. But typical several problem maybe solved by possible LLM or something like that. Yes.
Anyone else? Vanessa.
Yeah, it's on now. Thank you so much, Kurihara Sensei, for this very inspiring talk. I need some time to digest the scale part, but I have actually two questions. The first one is about the aging society in agriculture. I don't remember which number slide it was, but there's one thing that puzzles me, is that maybe there could be some other answers to this problem than, putting artificial intelligence. Maybe there's a problem with the fact that Japanese population is aging, and this may have to do with the fact that it's not so easy to have babies anymore, or that, maybe some adjustment could be done, or some policies could be done to make life better so that people would like to have more babies. So that's a very simple, answer to that, which is different from artificial intelligence. So maybe we don't need artificial intelligence for that, just, so to speak, to have more babies and to make things more comfortable, especially for women to have babies. So this would be a feminist view on what you said. And also about agriculture, maybe the life of people who are doing agriculture in Japan and other countries is not very easy, and maybe we need some policies to make their life more comfortable. So maybe the answer is not always artificial intelligence. This is my first question. My second question is about the concept of omotenashi, which I find really interesting. When you say that the next generation artificial intelligence will need omotenashi, do you think that artificial intelligence will really experiment and want and care about people so as to provide omotenashi, or will it be able, does it have to be able to mimic omotenashi?
So two questions, very different to understand. But as for first question was a very surface-like discussion. Okay, so of course I only think about the problem of labor. Yeah. So your point is of course overlapping in my presentation. Of course, I'm sorry. Yeah, thank you. Yeah, and for second question, I think omotenashi is one of interaction mechanism. So I use the omotenashi to show the how to omotenashi is a proactive thinking. Okay, to make a proactive agent must autonomously something guess or see or something think about the human intention, something like that. To make this, I use omotenashi. Okay. Of course, if this is AI and omotenashi to I think that this AI is very understand my feeling. So in this case, to continue the interaction, maybe human something think reliability on AI is my also optimistic, but my thinking to construct a ideal symbiotic relationship between human and human. So first interaction technique is omotenashi. Omotenashi is something my good keyword. Could be very good. I think a very good keyword. I think, yeah.
I think we have time for one more, please.
Thank you for the very nice presentation. Yes, one of the key words in your presentation was autonomous. From my understanding, autonomous is not a binary, but it is a scale. So what is your definition of autonomous? And my second question is that when you talk about the EU Act, you also related to the autonomous, but from my understanding, it is more like the classification for the use cases. And how do you relate this to autonomous, the prohibited AI systems?
Yeah. And for the first question,
thank you.
first question is first question first is I'm sorry. Autonomous thing. Yeah. My autonomous thing is to make autonomous AI, important points are how to select multi-goal. Okay. So with the autonomous AI to be autonomous, AI must have something purpose. Purpose is very important, I think. And autonomous AI's condition is how to AI think about its purpose, multi-purpose. And multi-purpose has which purpose is a very priority higher role. Think changes reactively very knowledge. Then this is my autonomous AI is something technical definition. Yeah, and in this case, why I think autonomous AI, maybe EU people think about the prohibited AI system because autonomous AI will interact actively with something subliminal or propaganda is a very serious problem of prohibited AI. So maybe autonomous AI is classified into this top area, I think, yeah. I'm sorry to, my answer is the best answer now, but something else.
Interesting point. Could I follow up on your answer? Maybe just pose a question. Now, the technology is AI. A-bomb, atomic bomb, is that a technology? So when United States developed A-bomb, it never prohibit, as you said, that to bomb civilians, but the atomic bomb was created and was used in Japan land. I'm going to Hiroshima just after this conference. So I wonder whether technology should be prohibited in any way. If you prohibit it, maybe that's not the real technology like intelligence. Maybe if we prohibit AI systems, then AI system never be intelligent at all. We just pretend to do things that's wasteful.
I'm sorry, very difficult question. So I'm sorry, I understand your question. This is during this presentation time. So I think later, yeah, I think we'll discuss later. Yeah, so thank you very much. Yeah.
Thank you very much. どうもありがとうございます。
Thank you for your presentation.